It's exciting to come your way once again as we delve into additional mathematics. In our previous lesson, we have considered the associative property where we considered an example. My name is Nana Yawedu and you can call me Sir Nana. Please ensure that you practice more, like and share my video, comment at the comment section, and subscribe to my YouTube channel so that you can get more videos when I put them there. In this lesson, we want to look at another example on the associative property. We need to do that because it's important for us to practice so that we'll get familiarized with how to solve questions on associative property. Now let's consider the question. So the question says that a binary operation star is defined on a set of real numbers r by m operation n to be equal to m plus n all over mn. And we are to determine whether or not the operation is associative. So let's look at the expected solution for this question. So with this question, we have been given an operation as m operation n. So the operation is m operation n to be equal to m plus n all over mn. Now, the question is asking us to determine whether or not the operation is associative. So in being able to determine that, you must be able to write out the law or the rule or the theory. So we say that for associativity, in this case, we are dealing with m and n. So we are going to have m operation n. So we'll put the first two into brackets and then we'll introduce another one. Probably this time, let's introduce p. Operation p is equal to m. So we'll take the first one, operation, the second two, so n operation p, right? We can say that where m, n, and p, which is a new variable we've introduced, are a member of the real number system. Now, let's consider the left-hand side. So m operation n into brackets operation p. So in this case, we'll consider the normal one that we know, which is even in the question, m operation n. And that gives us what we have here, m plus n all over m n, right? So as we said this time, we know that this m operation n is being replaced by m plus n all over mn. So we are going to have m plus n all over mn, replacing m operation n, and that will operate on the p, so operation p, right? And we are going to put these two into the main operation that we have here. So what we are going to do is that wherever we have our m, we are going to replace it with m plus n all over mn, right? And then wherever we have our n, we'll replace it with the p in the operation here. So that means that we are going to have our m plus n all over mn operation p to be equal to m plus n all over mn, which is now for m, plus p all over m plus n all over mn multiplied by p. Now let's simplify this. So to simplify this, let's consider the denominator first, which is the one down here. So we can rewrite or simplify the denominator, right, as we have m plus n all over mn operation p to be equal to our denominator. It means that the p will multiply just the top part, because multiplication, this is seen as p over 1. So you are going to have mp plus np all over mn, right? And then the top part, because it's fraction, it's like having a fraction like 1 over 3 plus 4. What you do is that you divide the 4 by 1, and then you are going to find your LCM. So your LCM here will be 3 and then 1. The LCM will be 3. And then you divide 3 by 3, gives us 1. Multiply by the 1 at the top, and that gives us what? 1. Then 3 will go here, 3, multiply by 4, it gives us 12. So the same process for which we do this is the same process we will take this through, right? So it means that we are going to have our m plus n all over mn plus p all over 1. And that implies that our m plus n all over mn operation p will be equal to, here we have mn as the LCM for the top part, and then mn will go into mn1, so you have m plus n, and then here it is going to be plus mnp, right? Because this is also dividing here, we can write it as a division sign here. Then we are going to have mp plus np all over mn. So we see a whole lot of variables here. So it means that m plus n all over mn operation p will now become m plus n plus mnp all over mn. Now the division will have to change to multiplication before we can simplify. Then once that happens, we have to reciprocate this. It means the mn will have to move up, and the mp all over mp will have to move down. This is something we do when we are dealing with division from our primary time to our JHS time, right? So you are going to have mn at the top all over mp plus np, right? So it means that our m plus n all over mn operation p will be equal to, this will cancel this. So you have m plus n plus mnp all over mp plus np. So we can replace this with what we have here. So it means that our operation m, operation n, all operation p will be equal to m plus n plus mnp all over mp plus np. And we'll call this equation 1. So now we are going to consider the right-hand side. So on the right-hand side, we have our m operation n, remember, to be m plus n all over mn. And our right-hand side is m operation n operation p. So we have our n operation p into bracket, right? So we have our n operation p into bracket. So it means that we want to take our n operation p. So that implies that wherever we see our m, we have to replace it with our n. Wherever we see our n, we replace it with our p in the operation here, right? So it means that our n operation p will be equal to n plus p all over np. Right, so now wherever we see n operation p, we can replace it with this. So we'll have m operation n plus p all over np, right? And this time as well, it means that wherever we see our m, we'll put our m there, here, right? Now wherever we see our n, we'll replace it with this whole thing, n plus p all over np in the operation. So we are going to have m operation n plus p all over np will become m plus p all over np, right? This time we are familiar, so you can write it this way and bring our division sign, right? That is the all over here. So we'll have our m multiplied by m plus p all over np, right? So it means that when you are simplifying this, m operation n plus p all over np will become, here we will have m over 1. So we have np as a LCM. This will go here np. So we have mnp. Plus this will go here 1. So n plus p. Right. Divided by this multiplying the top. So we have mn plus mp all over np. Right. So now that we have this, we can actually change it to become m operation n plus p all over np, right, which will be equal to mnp plus n plus p all over np. Right. The division will change to multiplication, so it means that we'll reciprocate. Right. The np will move to the top, and the mn all over np will move down. So we are going to have np at the top all over mn plus mp. So mp will cancel mp. It means that our m operation m plus p all over mp will become mnp plus n plus p all over mn plus mp. So we can say that on the other hand, the m operation n into bracket operation p is equal to mnp plus n plus p all over mn plus mp. Now let's call this equation 2. So we have to look at equation 1 and compare with equation 2. So let's consider equation 1. So we have m plus mnp all over mp plus mp. So we have m plus n plus mnp all over mp plus mp. Right. So it means that m operation n operation p, which is the first part, right, gives us this. So this is equation 1. So now we can compare the equation 1 and the equation 2. Now we see we have mnp at the top here. We also have mnp here. Now in the top here we have n. We have n here. And then the top here we have m. But here we have p, right? Here we have mp, we have mp. Then we have np, but then we have mn. So it means that they are not the same. So we can say that since equation 1 is not equal to equation 2, then the operation star is not associative. So we can actually consider this question where we have actually looked at an operation where we can see that this operation is not associative. You can look at it in general here, where we are actually looking at it. We can have everything here. So you could see that we went through the process here where we were able to determine the first part to have it as m plus n plus mnp. And then we had it all over mp plus mp. And then we had the second part as m plus n plus mp all over mn plus mp. And then we are able to conclude that they are not associative because the first one does not correspond with the second one. It involves a lot of algebra works that involve dealing with a lot of variables. So you must take your time, go through it, and you'll be good to go. In our next lesson, we'll be considering the distributive property. See you in the next lesson.